In this example, we're going to solve an absolute value equation. When dealing with an absolute value equation, the first thing you want to do is isolate the absolute value portion on one side of the equal sign. So what I'm going to do first is I'm going to add 6 to both sides. That's going to give us 3 times the absolute value of 2x plus 1 is equal to 15. Notice that we still don't have the absolute value portion fully isolated over on the left-hand side. We need to divide now by 3. Division by 3 gives us 2x plus 1 in our absolute values is equal to 5. From here, what we want to do now is to divide this into two different cases. We could have the case that 2x plus 1 is equal to positive 5, in which case the absolute value signs won't change anything. Or we could have that the inside, 2x plus 1 is equal to negative 5, in which case the absolute values are going to change this into a positive 5. So we're going to consider both of those cases. And what we do is we solve each of these cases separately as its own linear equation. For our first linear equation, we could subtract 1 from both sides. That's going to give us 2x is equal to 4. And then dividing both sides by 2 gives us x is equal to 2. For our second linear equation, once again we could subtract 1 from both sides. This gives us 2x is equal to negative 6. And then dividing by 2 gives us x is equal to negative 3. Now what you want to get into the habit of doing is double checking these solutions. So first I'm going to substitute x is equal to 2 into our original absolute value expression and see if we get 9. Substituting 2 in for x, we're going to get the absolute value of 5, which is equal to 5. 3 times 5 is 15, and if we subtract 6, we do get 9. Next, let's substitute in x is equal to negative 3 into our absolute value expression, and once again see if we get 9. Substituting negative 3 in, we're going to have 2 times negative 3, which is negative 6. And negative 6 plus 1 is negative 5. Now the absolute value signs are going to return back a positive 5, so we're going to get 3 times positive 5 here, which is 15. And subtracting 6 gives us 9. So it turns out that both of our x values are valid solutions to the original equation.